Welcome again to this online course on chemical process safety. Since you have enrolled in this course, then we can safely assume that you are entering the workforce and perhaps freshly joining a petroleum refinery or a chemical plant. So congratulations and welcome to the chemical industry. In the chemical, petrochemical, and most other industries, you will find that all companies are required to have an occupational safety program with a focus on personal safety. The objective is to prevent harm to workers from the workplace accidents such as falls, cuts, being struck by object, repetitive motion injuries, and so on. They are good and, in fact, very necessary programs. They are not, however, what process safety is about. Process safety is defined as a discipline that focuses on the prevention of fires, explosions, and accidental chemical releases at chemical process facilities. Such events don't only happen at chemical facilities, they occur in refineries, offshore drilling facilities, gas plants, steam plants, and so on. This makes working at one of these industrial facilities very challenging, and safety must be your top priority. In this introductory video, we will present a few basic, simple, but important safety rules to remember in order to stay safe while enjoying your daily job. Then, in later sessions, we will tackle advanced process safety topics such as confined space entry, control of work, safe handling of hydrocarbons, safe startups and shutdowns of process units, and hazards of trapped pressure and vacuum, just to name a few. Now, keep in mind here, the good news is the following simple safety rules are applicable regardless of your chemical plant location. The first rule, use your personal protective equipment, PPE. On oil and gas sites, chemical plants, and most industrial facilities, required PPE usually includes hard hats to prevent a risk of head injury from falling objects, safety glasses for eye protection, earplugs or ear muffs for hearing protection, gloves and boots for hand and foot protection, and fire-resistant clothing. In later videos, we will provide more details on PPE specific to each job activity that you may encounter at refineries and chemical plants. The next basic safety rule is know the nature and extent of hazards at your facility. Now, this safety rule may sound relevant to technical staff only, but we strongly recommend and encourage non-technical staff to quickly become familiar with the hazards likely present at their facility, so that they can develop safe behavior and recognize early signs of safety concern. In oil refineries, for example, dangerous events which might be anticipated are release of flammable vapor clouds which may give rise to fires or explosions. This was the case at an ethylene plant in Texas, as highlighted in this video.
Shortly before 10:30 a.m., the emergency pressure relief system activated. High-pressure ethylene vapor discharged from the reactor into the atmosphere. It was released horizontally toward an area where many people were working, rather than vertically to a safe location. Soon after, a nearby welding machine likely ignited the vapor, and a large fire erupted. 23 people were injured.
Other dangerous events include release of flammable liquid, followed by pool or flash fires, similar to what happened at a petroleum terminal facility in Puerto Rico, as highlighted in this video.
The supervisor estimated that Tank 409 would be full at 1 a.m. But shortly before midnight, Tank 409 started to overflow. Gasoline sprayed from the vents, forming a vapor cloud and a pool of liquid in the tank's containment dike. The CSB determined that a total of nearly 200,000 gallons of gasoline, the equivalent of 20 full tanker trucks, was released from the 6 vents on the tank. On a warm, windless night, the gasoline vapor cloud grew to cover an area of 107 acres. The pooled gasoline flowed through open valves in the containment dike toward the wastewater treatment area. There, the vapor reached electrical equipment, which ignited the cloud. A flash fire raced back toward the storage tanks. 7 seconds later, there was a massive explosion, registering 2.9 on the Richter scale.
Other dangerous events include release of toxic gases, similar to the chlorine gas leak at Aqaba Port in Jordan, killing 12 people and injuring hundreds of workers. Other dangerous events include internal fires or explosions due to air ingress into equipment containing hydrocarbons, or due to hydrocarbon ingress into air systems, similar to the FCC explosion at ExxonMobil refinery in the US.
A flammable hydrocarbon mixture was flowing through the air side of the FCC unit and moving toward the ESP with its multiple ignition sources. There, the flammable hydrocarbon mixture violently exploded.
Other dangerous events include fires from pyrophoric matter and other spontaneously combustible material as highlighted in this video, Lastly, spillage of heavy hydrocarbons with soil and water contamination are among the dangerous events which can occur at a refinery, as highlighted in this video.
At approximately 10 a.m., the hazardous mixture of air and hydrocarbons found an ignition source, and there was a large explosion. Debris from the explosion flew about 200 feet and hit a large above-ground storage tank, puncturing the side of the tank and releasing hot asphalt. Asphalt poured out of the tank over the containment berm and into the refinery's operating units, where it spread along the ground. At around 12:15 p.m., the released asphalt ignited near the storage tanks, and the fire broke out. The fire traveled along the stream of asphalt to the refinery's crude and FCC units. The fire produced a huge plume of black smoke, leading to the evacuation of a portion of the town of Superior. Typically, this type of asphalt fire can burn for days.
These events could be caused by corrosion, equipment failure or malfunctioning, design deficiencies, human error or deliberate act, or natural conditions such as storm, tidal wave, or earthquake. Now, at this stage, don't worry if some of the hazards highlighted here are not clear for you. We will demystify them in an easy-to-understand format further ahead. Next, do not smoke at your facility unless in authorized outside designated safe areas. Because of the inherent characteristic of refineries, chemical and gas plants, there are areas of your facility where the explosive gas is present or likely to occur during normal operation. As a result, smoking, as well as open ignition sources in these areas, are strictly prohibited. In addition, do not use your cell phone at your facility unless it is an explosion-proof device. Cell phones are not designed for use in an ignitable atmosphere. In fact, some owners' manuals clearly say this. It is possible for a spark, powerful enough, to create an explosion. One way this can happen is if the phone is dropped, the battery pops out, and something bridges its terminals, creating a short. In other instances, defective circuitry inside the phone are capable of doing the same. Now, the chances of all this coming together at the precise same moment is distinctly remote, but even so, extreme caution is advisable. So please switch off your phone when you are at your facility. Next, know the location of the assembly points. Assembly points are established at your facility for use in the event of evacuation. They are at a position which is unlikely to be affected at the time of emergency. On your facility layout, they are represented by the following symbol. Next, know your evacuation procedures and emergency plans. Each refinery and chemical plant has an emergency plan. When an emergency occurs, the main concern is to preserve life and safeguard property and the environment. Therefore, an emergency plan, catering for both minor and major emergencies, is designed with the following objectives: rescuing people, treating the injured, safeguarding others, minimizing damage to property and environment, controlling the incident, removing the hazard, preventing escalation, identifying casualties, informing and assisting relatives, informing the news media, and informing and collaborating with the authorities and emergency services. The plan also includes the action to be taken by staff in the event of an emergency, the evacuation procedure, and the arrangements for calling the fire and rescue authority. At refineries and chemical plants, notices giving clear and concise instructions of the routing to be followed in case of an emergency are prominently displayed. This is depicted in the following example. This is a fire evacuation diagram that includes the location of the assembly point to which staff escaping from the workplace should report and the routing to be followed. So it is really important that you become quickly familiar with the means of escape in case of emergency and the routing to be followed. Next, know and understand the meaning of your facility alert siren. A siren, as seen here, is an alerting device which alerts you to a possible hazard in your area. The sound of a siren is meant to draw your attention away from your daily activities. The following is a typical example of a siren sound. The best response to hearing a siren is to take protective action. These may vary from plant to plant. For example, at our refinery, in the event of a gas leak, the siren sounds continuously for 3 minutes. In the events of a fire, the siren sounds continuously for 1 minute, then stops for 30 seconds, then sounds continuously again for 1 minute. In both cases, the work must be stopped immediately, and the facility must be evacuated towards assembly points. In addition, at our facility, the sirens are tested weekly on Wednesday at noon for 30 seconds. In this case, the evacuation is not needed. Next, always use your personal ID card to access or exit your facility. Now, there are dozens of reasons businesses decide to use employees and visitor IDs. These can range from improving the overall security of your company to just helping everyone remember each other's names. From a safety perspective, your personal ID card is also a way to keep in tracking of your facility entry and exit times. And in cases where evacuation becomes necessary, the roll call will be facilitated, since a complete list of the names of all staff is maintained and readily available. The management and safety team will easily identify whether or not all employees have successfully evacuated the plant. Finally, it is important that you know the emergency telephone numbers. These are part of your facility emergency plans and typically include the following numbers: fire service, security service, medical service, emergency manager, and control room. These response teams, together with shift personnel of all departments, form the internal control services. PPE includes all equipment which is intended to be worn or held by a person at work and which protects them against one or more risks to their health and safety. On oil and gas sites, chemical plants, and most other industrial facilities, required PPE usually includes hard hats to prevent a risk of head injury from falling objects, safety glasses for eye protection, earplugs or ear muffs for hearing protection, gloves and boots for hand and foot protection, and flame-resistance clothing. The figure shown now on screen is self-explanatory and illustrates the poor and corrected version of PPE use. Keep in mind here that it is the duty of every employer to ensure that suitable PPE is provided to their employees who may be exposed to risks to their health and safety, except where it has been adequately or more effectively controlled by other means. Now, the benefits of PPE are: it gives immediate protection to allow a job to continue while engineering controls are put in place. In an emergency, it can be the only practicable way of effecting rescue or shutting down plant in hazardous atmospheres. It can be used to carry out work in confined spaces where alternatives are impracticable. But it should never be used to allow people to work in dangerous atmospheres which are, for example, enriched with oxygen or potentially explosive. However, it is important to keep in mind here that PPE should only be used as a last resort. There are many reasons for this. The most important limitations are that PPE only protects the person wearing the equipment, not others nearby. PPE relies on people wearing the equipment at all times, and they must be used properly, and must be replaced when it no longer offers the correct level of protection. This last point is particularly relevant when respiratory protection is used. PPE should not be suitable unless it is appropriate for the risks and the conditions of use, including the period for which it is worn. PPE should not be suitable unless it is capable of fitting the wearer correctly, and it is able to combat the risks without increasing overall risks, and it complies with local legislation on design or manufacture. For example, in Europe, it must have a CE marking. In this example, the CE marking on the safety glove is highlighted here. Of course, PPE must be provided to a person solely for their individual use. It is also the duty of every employer to ensure that any PPE provided is maintained, including being replaced and cleaned in an efficient state, in efficient working order, and in good repair. A recommended practice is to set up an effective system of maintenance for PPE. This should be proportionate to the risks and appropriate to the particular PPE. It could include cleaning, disinfection, examination, replacement, repair, and testing. For example, mechanical fall arrestor equipment will require planned preventive maintenance with examination, testing, and overhaul. Records should be kept of the maintenance work. Gloves may only require periodic inspection by the user as necessary, depending on their use. In some cases, these requirements can be fulfilled by using disposable PPE, which can be discarded after use or when their life has expired. The point here is that you should know when to discard and replace these disposable PPE. Your employer must ensure that the information is kept available and should, at suitable intervals, organize demonstrations of the wearing of PPE. The training you will receive should include an explanation of the risks and why PPE is needed, the operation, performance, and limitations of the equipment, as well as instructions on the selection, use, and storage of PPE, problems that can affect PPE relating to working conditions, defective equipment, hygiene factors, and poor fit, the recognition of defects and how to report problems with PPE, practice in putting on, wearing, and removing PPE, practice in user cleaning and maintenance, and how to store safely. Some key points will be provided further ahead. To finish off this video lecture, keep in mind and always remember, as a potential actor in an oil refinery, a chemical plant, or any other type of industrial facility, you are responsible for the health, safety, and welfare of yourself, your fellow workers, and all those who work or visit your facility. As a consequence, it is your duty to enforce PPE requirements, make spot checks to determine that protective equipment is being used, and periodically appraise condition of equipment.
If you work around flammable chemicals or gases that could ignite and boom, explode, or around high voltage electrical equipment where you could face an electric arc flash explosion, you probably wondered how bad it would really be if an accident happened and you weren't wearing flame-resistant clothing. I could tell you some horror stories, but you're not here to listen to me talk, you're here to watch it burn. You don't want to be the guy wearing those.
Fire! Fire!
Watch what happens when we try the same test with flame-resistant DuPont Nomex coveralls, just like I'm wearing. Unlike other fabrics, flame-resistant fabrics either self-extinguish when exposed to flame or simply never ignite at all. That seems much safer to me.
Safety sign means a sign referring to a specific object, activity, or situation, and providing information or instruction about health and safety at work by means of a signboard, a safety color, an illuminated sign, an acoustic sign, a verbal communication, or a hand signal. A safety sign is used where there is a significant risk to health and safety that has not been avoided or controlled by other means, like engineering controls or safe systems of work, and where the use of a sign can help reduce the risk. A simple example is when a wet area of a floor is not cordoned off and a wet floor sign, as depicted now on screen, is used to warn workers of a slippery area. Safety signs apply to all workplaces and to all activities where people are employed, but exclude signs used in connection with transport or the supply and marketing of dangerous substances, products, and equipment. Signboard means a sign which provides information or instructions by a combination of a geometric shape, color, and a symbol or pictogram, and which is rendered visible by lighting of sufficient intensity. Examples of signboards are now shown on screen. Acoustic signal means a coded sound signal which is released and transmitted by a device designed for that purpose, without the use of a human or artificial voice. This typically refers to the emergency sirens which were discussed in a previous video. Verbal communication means a predetermined, spoken message communicated by a human or artificial voice. Hand signal means a movement or position of the arms or hands or a combination in coded form, as seen here, for guiding persons who are carrying out maneuvers which create a risk to the health and safety of people at work. This will be discussed in detail further ahead. Now, safety signs used in refineries and chemical plants include a pictorial symbol categorized by shape, color, and graphic image. A red circular band with diagonal crossbar on a white background, as depicted here, with a black symbol within the circle, denote a safety sign that indicates that a certain behavior is prohibited. In this example, smoking is prohibited. A yellow triangle with a black border and a symbol within the yellow area denotes a safety sign that gives warning of a hazard. In this example, the sign indicates that the roof is fragile. A blue circle with a white symbol denotes a sign that indicates that a specific course of action must be taken. This example indicates that a safety helmet must be worn. A green square with a symbol or text in white denotes a safety sign providing information about safe conditions. In this example, the sign indicates the presence of a safety shower. A red square with a symbol in white denotes a safety sign that indicates the location of firefighting equipment. In these examples, the location of a fire extinguisher or a hose reel. Now, in general, safety signs in refineries and chemical plants can be broken down into 6 categories. These are prohibition signs, warning signs, means of escape and emergency equipment signs, fire safety signs, mandatory action signs, and signs for globally harmonized systems of classification and labeling of chemicals. Now, while it is obviously impossible to address every safety sign ever made, here is a short summary of the most frequent signs encountered in refineries and chemical plants. We strongly encourage you to learn their meaning and be familiar with them. Let's start with the prohibition signs. The following sign indicates that it is not allowed to smoke in this area, typically because of an explosive atmosphere. The next sign indicates that fire, open ignition sources, and smoking are prohibited. This sign indicates that access is not allowed for unauthorized persons. This one here indicates that access is not allowed for pedestrians. And this one, access is not allowed for forklift trucks or any other industrial vehicle. The next sign indicates that in case of fire, water should not be used as an extinguishing agent. Actually, from the sign, we can assume that the type of fire likely to occur in this area is a flammable liquid fire. In this particular case, water is extremely ineffective at extinguishing this type of fire, and you may in fact spread the fire if you try to use water on it. Also, as a side safety note, never use water to extinguish an electrical fire. These hazards will be discussed in more details further ahead. The next sign is simply a do not touch safety sign. You can find this sign next to hot surfaces or extremely cold piping, such as those encountered in liquefied petroleum gas systems. Warning signs are also almost everywhere in refineries and chemical plants. Here is a collection of the most used ones. Recall, a warning sign denotes a safety sign that gives warning of a hazard. In this example, the hazard is associated to the property of the material being used, which is a flammable gas or liquid. Thus, smoking and open ignition sources are strictly prohibited when handling this material. The following sign indicates that the emergency exit is located to the left, while this one indicates that the emergency exit is located to the right. It is important to know the meaning of these signs in case of emergency evacuation. These are life-saving signs. The next couple of signs show the location of first aid facilities, such as eye wash stations and safety showers. A fire safety sign is a red square sign with a symbol in white, denoting a particular safety equipment and indicating its location. The following examples are for fire extinguishers, fire hose reels, ladders, fire alarm call points, and emergency fire telephones. A mandatory action sign is a blue circle with a white symbol indicating that a specific course of action must be taken. The following examples for mandatory protective equipment are quite common in refineries and chemical plants, and remind workers of the mandatory PPE as a function of the job being carried out or the location in the plant. For example, some types of maintenance activities, such as grinding or sandblasting, will require workers to wear a face shield, since fragments given off during these processes can cause eye injury. Another important mandatory safety sign is for work at height, indicating that a safety harness must be worn. Work at height will be discussed in more detail further ahead. Next, the following signs are for the classification and labeling of chemicals. This first sign indicates that heating of the chemical involved may cause an explosion. So the safety message here is keep away this chemical from heat, sparks, open flames, hot surfaces, and any other source of ignition. The second sign indicates that heating of the chemical being used may cause a fire. So it is advisable to keep this chemical in its original container and away from any source of ignition. This sign is for oxidizers. Oxidizers are chemicals which intensify fire. So in the presence of this sign, please take any precaution to avoid mixing with combustibles. The next sign is for corrosive materials. These can cause serious skin or eye damage. So remember to wear the adequate PPE while manipulating, handling, or storing these chemicals. By adequate PPE, we mean, at a minimum, protective gloves, a protective clothing, a face shield, and safety boots. The next sign is for toxic materials. So please keep in mind here, do not eat, drink, or smoke when using this type of chemicals. This sign indicates that the chemical is toxic to aquatic life with long-lasting effects, so please avoid releasing this type of chemicals to the environment. The next 3 safety signs that you can see now on screen are relatively new. They were introduced a couple of years ago. The first one reflects chemicals that can cause serious longer-term health hazards such as carcinogenicity and respiratory sensitization. The chemicals involved may cause allergy or breathing difficulties if inhaled. So keep in mind here, for your safety, when using this type of chemicals and in case of inadequate ventilation, please wear a respiratory protection. The next sign or pictogram refers to chemicals causing less serious health hazards such as allergic skin reactions. In this particular case, contaminated work clothing should not be allowed out of the workplace and must be safely discarded after contamination. The last symbol is used when a container holds gas under pressure. The hazard here is that the container may explode when heated. The following figure depicts for each hazardous chemical the minimum PPE requirement. Notice here that we said minimum requirement. Why is that? Because PPE requirements may differ from a company to another. Some companies may be more conservative when handling a certain type of chemicals. So always consult your company safety advisor and safety guidelines. Okay, great. Now, keep in mind here, it is not the intention of this video to enter into details regarding the subject of chemical hazards or specific job hazards. These complex subjects will be discussed in much further depth in the next couple of modules. Don't forget that all of the safety symbols discussed in this video are available for download in the downloadable resources section of the course. Hand signal means a movement or position of the arms or hands or a combination of both in coded form for guiding persons who are carrying out maneuvers which create a risk to the health and safety of people at work. A typical example of risky maneuvers where coded hand signs are used is lifting operations. It is important that you are familiar with these codes for your own safety. These coded hand signals can be broken down into 4 categories. These are general signals, signals for vertical movements, signals for horizontal movements, and danger signals. The figures that will follow will provide valuable insights into each type. In the first figure, we can see an operator with both arms extended horizontally with the palms facing forwards. This notifies the start of the operation. In this next figure, the right arm of the operator points upwards with the palm facing forwards. This indicates the end of movement or a stop. Here, both hands are clasped at chest height. This indicates the end of the operation. In this example, the operator's right arm points upwards with the palm facing forward and slowly makes a circle. This indicates a vertical upward movement or a raise signal. When the right arm points downwards with the palm facing inwards and slowly makes a circle, it indicates a vertical downward movement or a lower signal. This next figure is for vertical distances. Here, the hands indicate the relevant distance. Now, for horizontal movements, when both arms are bent with the palms facing upwards and the forearms make slow movements towards the body as depicted here, then this indicates a move forwards signal. When both arms are bent with the palms facing downwards as seen here, and the forearms make slow movements away from the body, then this indicates a move backwards signal. The next hand signal is self-explanatory. When the right arm is extended more or less horizontally with the palm facing downwards and slowly makes small movements to the right, it indicates a horizontal movement on the right side, as opposed to this hand signal indicating a horizontal movement on the left side. This next figure is for horizontal distances. Here, the hands indicate the relevant distance. Finally, a dangerous situation can be indicated by the following hand signal. In this situation, an emergency stop is required. Now, it is essential to ensure that people can escape quickly from the facility in the event of fire or other emergency. Your company has an emergency plan, including the action to be taken by staff and the evacuation procedure. A key element in this evacuation procedure is the evacuation diagram. The evacuation diagram is a detailed plan of the building or the facility, giving clear and concise instructions of the routing to be followed. It also includes the method of raising an alarm in the case of fire and the location of an assembly point to which you should report. These evacuation diagrams are displayed in common areas where they can be easily seen, as depicted in these examples. These evacuation diagrams are oriented in relation to the position of where you are standing when looking at them on the wall. A typical example of an evacuation diagram is shown now on screen. Here, we're looking at an evacuation diagram of a building. The "You are here" location is an important feature of the diagram, as it indicates where the diagram is placed in the building and provides guidance to you as to where you are currently located, so that you will easily determine the exit route leading to the assembly area. In this example, you would be located in office number 4, and the exit route would be as follows. The diagram also shows the emergency exits. These are always in green. In this example, 3 emergency exits are depicted on the diagram. In addition, some firefighting equipment are also shown. These include a carbon dioxide extinguisher, a water extinguisher and a fire blanket in hall number 1, a water extinguisher in hall number 2, and a fire blanket in office number 1. Okay, now as an exercise for you, we encourage you to examine the evacuation diagrams at your facility. Check that the escape routes are not obstructed, that exit doors are not locked, that your colleagues know perfectly where the assembly area is located, and that, most importantly, the diagram is up to date. One simple and quick way to check this is to look for the firefighting equipment indicated on the diagram and make sure they are consistent with what can be currently found on the field. Fire extinguishers are portable firefighting equipment. They are widely used in refineries and chemical plants. Their primary purpose is to tackle fires at a very early stage, to enable people to safely make their escape. Larger fires are then dealt with by the fire and rescue services. After completing this video, we encourage you to make a plant tour at your facility, identify where fire extinguishers are located, and examine their type. Keep in mind for your plant tour that fire extinguishers should be sited on exit routes, preferably near to exit doors or where they are provided for specific risks near to the hazards they protect. In addition, notices and safety signs indicating the location of firefighting equipment should be displayed where the location of the equipment is not obvious, or in areas of high fire risk where the safety sign will assist in reducing the risk to people in the workplace. Okay, now there are 4 main methods of extinguishing fires. First, we list them, then we will discuss each one of them in details. These are as follows: cooling, smothering, starving, and chemical reaction. The cooling method consists in reducing the ignition temperature by taking the heat out of the fire. This is usually done using water to limit or reduce the temperature. The smothering method consists in limiting the oxygen available by smothering and preventing the mixture of oxygen and flammable vapor by the use of foam or a fire blanket. The starving method consists in limiting the fuel supply by removing the source of fuel, or by switching off electrical power, or by isolating the flow of flammable liquids, or by removing wood and textiles. The chemical reaction methods consists in interrupting the chain of combustion and combining the hydrogen atoms with chlorine atoms in the hydrocarbon chain. This can be done using halon extinguishers. Keep in mind, though, that halons have generally been withdrawn because of their detrimental effect on the environment as ozone-depleting agents, so perhaps this type of extinguisher is not used at your facility. Now, fire extinguishers are all red, with 5% of the cylindrical area taken up with the color code. The color code denotes on which class of fire the extinguisher can be used. In this regards, there exists 5 classes of fire, These are Class A for paper and wood fires, Class B for flammable liquid fires, Class C for flammable gas fires, Class D for metal fires, and electrical fire class. It is important to understand the limitations of fire extinguishers so that you will be in a better position in case you will have to tackle fires at a very early stage at your facility. The figure that you can see now on screen depicts a typical example of a water extinguisher. Water extinguishers can only be used on Class A fires. They allow you to direct water onto a fire from a considerable distance. A 9-liter water extinguisher can be quite heavy, and some water extinguishers with additives can achieve the same rating, although they are smaller and therefore considerably lighter. It is important to keep in mind here, this type of extinguisher is not suitable for use on flammable liquid fires, on metal fires, or on live electrical equipment fires. In case of electrical equipment fires, water is a good conductor, and there is some concern for electrocution if you were to use water to extinguish an electrical fire. Electrical equipment must be first unplugged and de-energized before using water as an extinguishing agent. In case of flammable liquid fires, water is extremely ineffective at extinguishing this type of fire, and you may in fact spread the fire if you try to use water on it. The next figure is for a water extinguisher with additives. This type of extinguisher is suitable for Class A fires. They can also be suitable for use on Class B fires. When applicable, this will be indicated on the extinguisher, as in this example. Water extinguishers with additives are in general more efficient than conventional water extinguishers. Another type of extinguisher that you will come across at your facility is the foam extinguisher. This type of extinguisher can be used on Class A or B fires and is particularly suited to extinguishing liquid fires such as gasoline and diesel. They are widely spread in refineries and petrochemical plants. The animation that will follow shows foam extinguishers in action during the fire at the Husky Energy Refinery in the USA.
Then, when the fires within the refinery's units had been extinguished, the fire truck relocated so that it could spray the burning asphalt in the containment area with foam from the east. Around 5:30, an additional team began to attack the fire from the south, spraying foam from a monitor. At this point, the asphalt fire was completely surrounded within the containment area. With the fire contained, emergency responders were able to put out the asphalt fire at around 7 p.m. The asphalt fire had been extinguished in a matter of hours, as opposed to days, as had been initially feared.
Foam extinguishers should not be used on free-flowing liquid fires, unless you have been specifically trained, as these have the potential to rapidly spread the fire to adjacent material. In addition, they should not be used on electrical or metal fires as well. The next figure depicts a typical example of powder extinguishers. These can be used on most classes of fire and achieve a good knockdown of the fire. They can be used on fires involving electrical equipment, but will almost certainly render that equipment useless. Keep in mind here, for your safety, that because powder extinguishers do not cool the fire appreciably, it can reignite. In addition, powder extinguishers can create a loss of visibility, as seen here, and may affect people who have breathing problems and are not generally suitable for confined spaces. They should not be used on metal fires. Shown now on screen, a carbon dioxide extinguisher. This type of extinguisher is particularly suitable for fires involving electrical equipment, as they will extinguish a fire without causing any further damage. As with all fires involving electrical equipment, the power should be disconnected first. These extinguishers should not be used on metal fires. Lastly, a wet chemical fire extinguisher, as shown now on screen, is particularly suitable for fat fires. The intense heat in the fluid generated by fat fires means that when standard foam or carbon dioxide extinguishers stop discharging, reignition tends to occur. Wet chemical extinguishers starve the fire of oxygen by sealing the burning fluid, which prevents flammable vapor reaching the atmosphere. Okay, great. Now, the following table summarizes the key points of our discussion, shows the various types of fire extinguishers, their applications, and their limitations. In the next video, we will show you, step by step, how to use a fire extinguisher. Okay, now it is easy to remember how to use a fire extinguisher if you can remember the following acronym, PASS, which stands for Pull, Aim, Squeeze, and sweep. Step 1. Pull the pin. This will allow you to discharge the extinguisher. Step 2. Aim at the base of the fire. Notice here that we said the base of the fire. If you aim at the flames, which is frequently the temptation, the extinguishing agent will fly right through and will do no good. You want to hit the fuel. Step 3. Squeeze the top handle, as highlighted here. This will depress a button that will release the pressurized extinguishing agent in the extinguisher. Step 4. Sweep from side to side. Repeat this as necessary until the fire is completely out. Start using the extinguisher from a safe distance away, then move forward. Once the fire is out, don't forget to keep an eye on the area and be ready in case it reignites. Now, the animation that will follow provides more detailed instructions into how to use fire extinguishers.
Pull the pin so that you're able to discharge the extinguisher. A. Aim the extinguisher nozzle at the base of the fire. S. Squeeze the lever to discharge the extinguishing agent. Releasing the lever will stop the discharge. S. Sweep. Pointing the extinguisher at the base of the fire, move the extinguisher from left to right or back and forth in a sweeping motion until the fire is out. When the fire is out, continue to watch the fire to ensure the fire does not ignite once again. If the fire comes back, repeat the pass method. Recap. P. Pull the pin. A. Aim. S. Squeeze. And S. Sweep.
Safe systems of work are crucial in work such as the maintenance of refineries and chemical plants, where the potential risks are high and the careful coordination of activities and precautions is essential to safe working. In these situations, the safe system of work is likely to take the form of a permit-to-work procedure. Although permit-to-work procedures may vary from plant to plant, the underlying principles are the same. As a potential player in industrial facilities, it is important that you are familiar with the concept of work permit, the principles that apply to it, the level of details and type of information required for a work permit, and whether or not a work permit is required for a given application in the first place. This video will introduce you to work permits in refineries and chemical plants. A general form of work permit will be introduced. Then, in later sections, we will revisit work permit and discuss how they are applicable to high-risk activities, such as confined space entry. Now, to begin our discussion, it is important to keep in mind here that the role of the permit-to-work procedure is to provide a specialized type of safe system of work for ensuring that potentially very dangerous work is done safely. The good news is, this procedure has been fully developed and refined by the chemical industry. So, if you happen to work in a refinery or a chemical plant, then you can be assured that your company has an existing work permit system in place. So, after completing this video, we encourage you to have a look at your company work permit and familiarize yourself with its requirement and constituent parts. Keep in mind, the function of the permit-to-work procedure is to ensure that certain defined operations are prohibited without the specific permission of a responsible manager. This permission being only granted once stringent checks have been made to ensure that all necessary precautions have been taken and that it is safe for work to go ahead. It is the duty of the people doing the work to take on responsibility for strictly following and maintaining the safeguards set out in the permit, which will define the exact work to be done and the exact time scale in which it must be carried out. So let me be very clear here. No deviation from what was initially established in the work permit, no matter how small or insignificant, can be tolerated. Now, at some point in your career, you will be involved in the work-to-permit procedure, perhaps as a permit approver, or as a permit issuer, or as a permit receiver. So please keep this in mind for the safety of your facility, the safety of your fellow workers and yourself. And let me say this one more time, no deviation from what was initially established in the work permit, no matter how small or insignificant, can be tolerated. Okay, now the question is, what are the principles that apply to permits to work? Although the answer to this question may vary from plant to plant and from country to country, we have summarized here the most important principles. We have listed 6 principles to remember. Principle number 1, wherever possible, and especially with routine jobs, hazards should be eliminated so that the work can be done safely without requiring a permit to work. This is part of the inherent safer design philosophy. The essence of this philosophy is the avoidance of hazards rather than their control by added protective equipment or safeguards. Principle number 2, the permit must be recognized as the master instruction, which, until it is cancelled, overrides all other instructions. Principle number 3. The permit applies to everyone on site, including contractors. Principle number 4. Information given in a permit must be detailed and accurate. It must state, at a minimum, which plant or equipment has been made safe, and the steps by which this has been achieved, the type of work to be carried out, and the time at which the permit comes into effect. This will be discussed in detail in a later video. Principle number 5. The permit remains in force until the work has been completed, and the permit is cancelled by the person who issued it or by the person nominated by management to take over the responsibility. And lastly, principle number 6. No work other than that specified is authorized. If it is found that the planned work has to be changed, the existing permit should be cancelled and a new one should be issued. Recall what I have told you in the previous video. No deviation from what was initially established in the work permit, no matter how small or insignificant, can be tolerated. In the next video, we will present a general form of work permit and discuss its various parts. Okay, now how does a work permit look like? A typical permit document is now shown on screen. This form is for general purpose work permits. Keep in mind here, various types of work permit exist. Among them, we can list general purpose work permits, as in our example, hot work permits, confined space entry permits, work at height permits, and high voltage work permits, just to name a few. These permits will be discussed in detail further ahead. Depending on the type of work to be done, please make sure that you are using the adequate form. Now, a general purpose work permit document should specify, at a minimum, the following key items of information: the date, time, and duration of the permit, a description and assessment of the task to be performed and its location, as well as the plant or equipment involved and how it is identified, the authorized persons to do the work, the steps which have already been taken to make the plant safe, an identification of the potential hazards which remain or which may arise as the work proceeds, as well as the precautions to be taken against these hazards. These hazards can be documented in a separate risk assessment sheet and attached to the work permit. The permit document should also specify the action to be taken prior to the task being started, such as the isolation of sources of energy, the isolation of process inlets and outlets, emergency procedures and equipment, communication arrangements, and reference to any other relevant document, in addition to specifying the PPE requirements. Now, in accepting the permit, the person in charge of doing the authorized work certifies that 1. He has read, understood, and accepted the requirements of the permit. 2. He will ensure that everyone working under his supervision will strictly follow the requirements of the permit. And 3. Before the start of work, he will check the isolation points, in that the system or equipment on which he will do the work has been completely de-energized. The permit will also include spaces for signature certifying that the work is complete, and for signature confirming re-acceptance of the plant or equipment upon completion of work, as highlighted here. Okay, now the important question is, what are the types of work that require a general work permit? Notice here that we said general work permit. Special permits, such as hot permits or confined space entry permits, are not covered in this video. These will be dealt with in a later section. It is important that you know the types of work that require a general work permit so that you can work safely. Recall, as a potential player in refineries or chemical plants, at some point in your career, you will be involved in the work permit system. The general permit should be used for work such as alterations to or overhaul of plant or machinery where mechanical, toxic, or electrical hazards may arise. This is particularly important for large machines such as compressors, where visual contact between workers is difficult, or where work has to be done near dangerous parts of the machine, and where there are multiple isolations for energy sources. The general permit should also be used for work on pipelines with hazardous contents, work at height, work with asbestos-based materials, and excavations to avoid underground surfaces. The point here to remember is whenever you need to perform a job that falls into one of these categories, you must have a valid work permit, where all the required information, such as those discussed in the previous video, are clearly listed, stated, and identified on the permit. Okay, now to further illustrate the concept of general work permit, let's discuss the following scenario. Shown now on screen, a centrifugal pump driven by an electrical motor. This is a flexibly coupled, horizontal foot-mounted, overhung centrifugal pump. The main components of this pump are the electric driver, the flexible coupling, the centrifugal pump itself, and the connecting piping. Let's assume that you are asked to replace the flexible coupling. In this case, is a work permit required? And most importantly, how would you proceed in a safe manner? We invite you to pause the video, take a couple of minutes, and think about it. Then come back here and check your answer. Okay, now recall, as discussed in the previous video, a general permit should be used for work such as alterations or overhaul of machinery, where mechanical or electrical hazards may arise. This is typically the case here. You have a centrifugal pump, which is a rotating equipment driven by an electrical motor. Thus, both mechanical and electrical hazards exist. This definitely calls for a work permit. Okay, now how to proceed in a safe manner? First, it is important to note here that the flexible coupling is an external part of the pump. By external, we mean that this piece is not in contact with the fluid being handled by the pump. As a result, you won't be exposed to the process fluid, and thus you don't have to worry about the pump itself or its inlet and outlet piping. The safety focus will be on the mechanical hazards. The mechanical hazards involve the rotating nature of the flexible coupling. When in operation, this piece rotates with the motor and transmits the movement to the pump shaft. So, when accepting the permit, you must make sure that the source of energy was isolated. And before the start of work, you must test on the field the effective isolation of the electrical power, as highlighted here. This example shows a lockout-tagout system. The concept of lockout-tagout, more commonly known as LOTO, will be discussed in detail in a later video. Failure to do so will potentially expose you to the risk of having your clothing, your hand, or arm dangerously gripped by the rotating coupling in case an operator inadvertently starts the pump. So keep in mind, injuries due to contact with rotating parts can be severe, even at low rotating speeds. So only when these verification steps were done, you can safely start the replacement of the flexible coupling. Hot work includes cutting, welding, brazing, and any process involving the application of a naked flame. Drilling and grinding should also be included where a flammable atmosphere is potentially present. This is almost always the case in refineries and chemical plants. Now, hot work is potentially hazardous because it may act as a source of ignition in any process in which flammable materials are handled. And of course, it may act as a cause of fires in all processes, regardless of whether flammable materials are present. So, hot work should therefore be done under the terms of a hot work permit. The following figure depicts a typical example of a hot work permit. Although hot work permit varies from plant to plant and from country to country, the form depicted now on screen is quite complete and includes all information, details, and requirements for a safe operation. This form is actually provided by the courtesy of FM Global, which is an insurance company specializing in loss prevention services to refineries and chemical plants. This form is currently being used at our refinery. As stated on the document, this hot work permit is required for any temporary operation involving open flames or producing heat or sparks conducted outside a hot work designated area. The hot work permit should specify, at a minimum, the following key items of information: the date, time, and duration of the permit, a description and assessment of the task to be performed and its location, the name of the person performing the hot work, and the name of the person performing the fire watch. The fire watch is the person responsible for continuously observing hot work activity for the detection of and response to fires during the hot work operation. The fire watch has the authority to stop work if necessary and conduct essential steps for restoring safe conditions within the hot work area. For obvious reasons, the person performing the hot work cannot be the fire watch. That person is concentrating on his own work and will not be able to react quickly enough should the fire ignite. Therefore, another employee must be assigned the fire watch duty. In addition, the nature and frequency of the fire watch or fire monitoring should be specified. Is it a continuous fire watch? Is a fire watch also required post-work? And if so, for how long? The hot work permit should also specify the steps which have already been taken to make the plant safe. For example, isolating potential sources of flammable gases, or making sure control valves on water supply lines to the sprinkler system are locked open. Safety steps of this nature, as well as other required precautions, are highlighted on the right side of the present hot work permit. In accepting the permit, the authorizer certifies that the location has been examined and that the required precautions have been taken. So, this is briefly the underlying principles of hot work permits. Recall, this example is available for download in the Downloadable Resources section. In later sections, we will provide further details and practical examples relating to hot work activities and demonstrate how hot work permits are an essential document to guarantee safety at the workplace. Now, one of the most risky work at refineries and chemical plants is work in confined spaces. This video will briefly introduce you to confined spaces and their associated hazards. Then, further ahead in the course, you will find a dedicated section about work in confined spaces. Now, to begin our discussion, let's first be clear about what a confined space is. A confined space is defined as any place, including any chamber, tank, silo, pit, pipe, sewer, flue, well, or other similar space in which, by virtue of its enclosed nature, there arises a reasonably foreseeable specified risk. By specified risk, we mean any risk to a worker of serious injury arising from a fire or explosion, loss of consciousness arising from an increase in body temperature, loss of consciousness or asphyxiation arising from gas, fume, vapor, or the lack of oxygen, asphyxiation arising from a free-flowing solid or because of entrapment by it, or drowning arising from an increase in the level of liquid. Therefore, in refineries and chemical plants, confined spaces include tanks, whether sealed or open-top, silos, vessels, furnaces, columns, reactors, manholes, and large-diameter pipes. If you are involved in equipment inspection or plant turnaround activities, such as inspecting the internals of a distilling columns or inspecting the internal walls of a chemical reactor, then you will be exposed to work in confined spaces. And for your own safety, it is extremely important that you are familiar with the hazards associated with this type of work. We are not saying that work in confined spaces is dangerous and should be avoided at all times. We are saying that it is a high-risk operation, and when not properly prepared and allowed for, it can quickly become deadly. Many operators have lost their lives while working in confined spaces. The principal hazards associated with a confined space are the difficult access and exit, which can make escape and rescue more difficult. Now, since work in confined spaces is a high-risk work activity, we strongly recommend you to make a careful risk assessment. The following items should be included in your assessment: the work to be carried out, the working environment, the working materials and tools, the suitability of those carrying out the work, and the arrangements for emergency rescue. If your assessment identifies risks of serious injury from work in the confined space, then you should ask yourself a very basic question. Can we avoid entry to the confined space? Can't we simply do the work outside the space? If the answer is yes, then do not hesitate to do the work outside the space, even if additional arrangements or special tools must be in place in order to do so. You know, at our refinery, we stopped allowing operators going inside the distilling columns to inspect columns' internals. We now use a remote camera for internal inspection. Now, if entry to a confined space is unavoidable, then you must follow a safe system of work and ensure that adequate emergency arrangements are in place before the work starts. The safe system of work we're referring to must be developed using the results of your risk assessment to identify the controls needed to reduce the risk of injury. We will see this in detail in a later section. For now, keep in mind, at a minimum, the topics that will follow need to be addressed in a safe system of work for a confined space. Note here that we said at a minimum. Why is that? Because these are what we believe the minimum requirements for a safe confined space work. Before the work starts, the air inside the space should be tested to ensure that it is fit to breathe. If the air inside the space is not fit to breathe, then breathing equipment will be essential in addition to the provision of adequate ventilation. Also, the size of the entrance to the confined space must be checked. It must enable rapid access and exit in case of an emergency. It is important that workers are provided with special tools and lighting, such as extra low voltage equipment, non-sparking tools, and specially protected lighting. In addition, for optimum safety, a qualified rescue watcher must be designated. This person should and must remain outside the confined space and provide continuous supervision and monitoring of the operation. The rescue watcher must be equipped with adequate communication tools to enable communication not only with workers inside the confined space, but also to call for help in case of an emergency. In case the work is done in confined spaces, including rotating parts or moving equipment, such as chemical reactors with internal agitators, the isolation of mechanical and electrical equipment is required. Now, take a look at the following figure. It shows a safe confined space entry. Here, an operator is about to enter a confined space with a breathing apparatus. We can assume here that the air inside the space is not fit to breathe. The size of the entrance to the confined space is large enough to enable rapid access and exit in case of an emergency. In addition, a rescue watcher is outside the space, keeping an eye on the worker and ready to intervene if needed. It is important to note here the use of a rescue tripod. The nature of this confined space allows the use of such rescue equipment. Of course, the provision of suitable rescue and resuscitation equipment will depend on the confined space configuration and the likely emergencies identified. Where such equipment is provided for rescuers to use, training in the correct operation of the equipment is essential. In addition, rescuers should also be trained in all aspects of the emergency procedures and relevant first aid procedures. To finish off this video, keep in mind confined space entry requires a special work permit. This permit is essential to confirm that all the appropriate precautions have been taken. We will see this in detail in a later section. Work at height is perhaps one of the most underrated risky work activities at refineries and chemical plants. Yet, work at height accounts for more injuries and deaths than any other activity each year. The purpose of this video is to bring your attention to the serious risks associated with work at height. It is our hope that after completing this lecture, you will be familiar with safety requirements when working at height, so that you will be able to recognize early signs of safety deviation and be able to implement corrective actions. To put things into perspective, based on our experience during plant turnarounds and maintenance activities, we have found out that at least 1 in 5 maintenance teams failed to address work at height risks on our site. Okay, now to begin our discussion, let's first agree on the definition of work at height. Work at height applies to all operations carried out at height, with no minimum height requirement. As such, work at height includes all work activities where there is a need to control a risk of falling a distance liable to cause personal injury. This is regardless of the work equipment being used, the duration of the work at height involved, or the height at which the work is performed. Work at height includes access to and exit from a place of work. In refineries and chemical plants, work at height includes using a ladder, a step ladder or kick stool, working on a scaffold or from a mobile elevating work platform, working on the top of a container or a storage area, using cradles or ropes for access to a building or other structure like a distilling column or a reactor vessel, using man riding harnesses in equipment repair or loading and unloading operations, working near an excavation area or opening if a person could fall into it and be injured, and painting or sandblasting at height. Keep in mind here, as a potential player in refineries and chemical plants, you are expected to apply a 3-stage hierarchy to all the work you do, and which is to be carried out at height. These steps are the avoidance of work at height in the first place when applicable, the prevention from falling if the work at height is unavoidable, and the mitigation of the effect of falls should they occur. A risk assessment for working at height should first consider whether the work could be avoided. If this is not possible, then the risk assessment should consider the following issues. the nature and duration of the work, the competence level of all those involved in the work and any additional training requirements, the required level of supervision, the use of guardrails, two boards, working platforms, and means of access and exit, the required PPE such as helmets and harnesses, the presence of fall arrest systems such as netting or soft landing systems, the health status of the workers, and the possible weather conditions. In the next couple of videos, we will discuss this in further detail. Work on or near fragile surfaces also falls under the work at height category. A typical example of roof work in refineries and chemical plants is work on tank roofs or storage silos. Roof work is hazardous. It requires a specific risk assessment prior to the start of work. Particular hazards are fragile roofing materials, including those materials which deteriorate and become more brittle with age and exposure to sunlight. There must be suitable means of access to tank roofs, such as scaffolding or ladders, as well as suitable barriers, guardrails or covers where people work near to fragile materials, in addition to suitable warning signs indicating that a roof is fragile. It is important to note here that these warning signs should be on display at ground level, as depicted in this example. Now, having said that, the safe practical approach is the same as for general work at height. Work on a fragile roof should always be avoided, and this can be achieved by doing the following. Work from underneath the roof using a suitable work platform. Where this is not possible, use a mobile elevating work platform that allows people to work from within the basket without having to stand on the roof, as shown in this example. Now, if access onto the fragile roof cannot be avoided, perimeter edge protection should be installed and staging used to spread the load. Unless all the work and access is on platforms that are fitted with guardrails, the safety nets should be installed underneath the roof or a harness system used. Where a harness is used, it is important to ensure that adequate anchorage points are available. In all cases, roof work should not be attempted in poor weather conditions such as rain, ice, frost, or strong winds, or if slippery conditions exist on the roof. Winds in excess of 35 km per hour will affect the balance of a roof worker. Lastly, as a general safety rule, keep in mind a roof should always be treated as fragile until a competent person has ruled otherwise. Although the work at height regulations may vary from one country to another, here are recommended practices for safe work at height. First, all work at height must be properly planned and organized. All those involved in work at height should be competent. The risks should be carefully assessed, and appropriate work equipment is selected and used. In addition, the risks of working on or near fragile surfaces are properly managed, and the equipment used for work at height is properly inspected and maintained. For example, guardrails on scaffolds are at a minimum of 950 mm, and the maximum unprotected gap between the toe and guardrail of a scaffold is 470 mm. This implies the use of an intermediate guardrail, as highlighted here in blue, although other means such as additional toe boards or screening may be used. They also specify requirements for personal suspension equipment and means of arresting falls such as safety nets. When working at height, certain safety measures should be followed to prevent falls from occurring. These measures are, first, eliminate or avoid working at height in the first place. Keep in mind here, much of the work which is done at height could often be done, or at least partly done, at ground level, thus avoiding the hazards of working at height. A typical example of this is the partial erection of a scaffolding at ground level, and then the use of a crane to lift it into place at height. Now, when working at height is really unavoidable, then work from an existing safe workplace, such as a properly constructed working platform, complete with toe boards and guardrails, and ensure that there is sufficient work equipment or other measures to minimize the distance and consequence of a fall. This can be achieved by the use of collective measures rather than individual measures, for example, a handrail instead of a harness. And where this is not possible, then collective fall arrest equipment such as safety nets or even individual fall restrainers such as safety harnesses could be used. Keep in mind here, and always remember, only when none of these measures is possible should ladders be considered. Ladders should always be your last resort. We will explain the safety reasoning behind this further ahead. Another hazard associated with work at height is the risk of falling objects. A protection against these falling objects should always be provided. Workers and nearby operators should be protected by the use of covered walkways or suitable netting to catch falling debris. Waste material should be brought to ground level by the use of chutes or hoists as depicted in these examples. Waste material should never be thrown. Although this seems logic and quite trivial, you will be surprised by what you will experience on the field. As you will be involved in field inspection and safety walkarounds, you will notice that many operators and contractors will violate this basic safety rule. When this happens, and it will happen, it will be your duty to safeguard nearby workers and implement corrective actions against such deviation. In addition, we strongly advise you to store only minimal quantities of tools and materials on working platforms. And whenever there is a risk of head injury from falling objects, helmets or any other mean of adequate head protection must be mandatory. This rule applies not only to company personnel, but also to contractors, nearby workers, and visitors. Head protection signs must also be displayed around the site. Reach points. Leave that duty to your experienced colleagues. Now, before using a safety harness, we recommend 2 levels of inspection. First, a pre-use check at the beginning of each shift to check there are no visible or surface defects. 2. A detailed inspection undertaken at least every 6 months. However, for frequently used equipment, this should be increased to at least every 3 months, particularly when the equipment is used in tough environments such as steel erection and scaffolding. Remember to formally record the results of the inspection and keep track of that record. Now, any defects discovered by any of these inspections must be reported to the employer or to your safety manager as soon as possible, and the safety harness in question should be rendered unusable and unavailable for workers. Okay, let's now shift our attention to safety nets. Safety nets are widely used to arrest falls of people, tools, and materials from height. The following picture depicts a typical example of a safety net. It is important to keep in mind here that the correct tensioning of the net is critical. Only specialist companies are available to fit nets. Safety nets, however, have a limited application, since they are not suitable for use in low-level operation, where there is insufficient clearance below the net to allow it to deflect the required distance after impact. Safety nets should be positioned so that workers will not fall more than 2 meters in case they hit the ground or other obstructions. The next couple of videos aim to provide and share good practices for safe work at height. The pictures that will follow will be accompanied by green and red boxes. A green box or green tick, as depicted here, shows the correct practice. A red box or a red cross, on the other hand, shows the wrong practice. In this video, we will provide you with valuable insights into the correct use of a safety harness for safe work at height. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, the D-ring on your safety harness should always be located between shoulder blades, as depicted here. For optimum safety, we recommend you get a colleague of yours to check if you are wearing your harness correctly. Now, when using your rear D-ring, the anchor point should be behind you. If the anchor point is in front of you, ensure that your harness has a front D-ring for you to use. So, to put it simply, the best practice here is ensure that the D-ring on your harness faces the same side as the anchor point. The anchor point should be secured on structure that has been assessed as safe for use. So, do not start work if the anchor point is not secure. Keep in mind here, a structure should always be treated as not safe for use until a competent person has ruled otherwise. The bottom line here, ensure that anchor point is secured before starting work. Next, tighten chest and leg straps so that no more than 2 fingers can fit between strap and body. This simply means that you must ensure that your body harness is the correct fit. Now, while being anchored, move to the next anchor point with your second lanyard. Always maintain 100% tie-off. This common sense practice means that you must ensure that your lanyard is anchored at all times. Lastly, the lanyard should be hooked on the D-ring of your harness and the anchor point, as depicted here.
If a harness is not worn properly and you fall into it, you could seriously hurt yourself or be killed. So today, we're going to run through the proper donning of a harness, okay? Now, prior to donning a harness, it is extremely important that the end user go through and inspect their harness before donning. Very important. When we don our harness, we want to make sure that all of our buckles are disconnected. We simply put the harness on over our shoulders. We connect our chest buckle. We connect our leg buckles. We ensure that our dorsal D-ring is positioned between our shoulder blades at the back. Now we can feel that, or we can have a buddy help us position. Once that's done, we position our chest strap. We want it mid-chest. If it's too high and we fall into it, it could choke us. If it's too low and we do a head-first fall, we could fall out of it. So positioning the chest strap is important. We then position our leg straps and adjust our leg straps to fit. Proper adjustment of a leg strap is to be able to get a flat hand between the webbing and your leg on both sides. Not a fist, a flat hand. Okay? In addition, when we get properly fitted, the plastic belt keepers that are included on the product must be pulled down right above the buckles. The purpose of that is to keep the webbing in place so that as you move around during the day, the webbing doesn't back off and loosen. That is very important, and a lot of people don't know or understand the use of those. The other thing that is very important for us is to ensure that once it is donned, we have a buddy that is working with us, ensure that everything is positioned properly before we head up to working at height. Have a safe and productive day.
In this video, we will provide valuable insights into the correct way of inspecting a safety harness for safe work at height. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, check that the surface of your harness webbing is not damaged. In order to do so, hold the webbing with both hands and bend it into an inverted U shape to check for damage, as seen here. Do not use the harness if the webbing is damaged. Remember to always inspect your harness before every use. Inform your supervisor if your harness is loose, worn out, or cut. Do not use the harness if the webbing, D-ring, or any other part are damaged. The figure that you see now on screen depicts a typical example of a damaged safety harness. Notice here the various cuts and defects. This safety harness is not fit for use and should be rendered unusable and unavailable for workers. Next, ensure that the connector is not damaged. For this, check that the locking gear is not stuck. And of course, do not use the connector if any part is damaged. Inspect the energy absorber of your lanyard and look out for damaged surface. Look out for holes, cuts, or tears on the outer protective layer of the energy absorber. It is important to keep in mind here to not use the lanyard if the energy absorber has been activated before. This is why it is important to formally record the result of inspection and to keep track of that record. Next, check that your equipment has the label of the manufacturer. Check the expiry date of your equipment and feel free to ask your supervisor if you are not sure. Inform him if your equipment has expired. Lastly, do not make any marking on your harness as it may damage the harness. A harness must not have any marking, burn marks, cuts, or cracks. Again, inform your supervisor if there is any markings on the harness, other than those originally made by the manufacturer of the harness, when applicable. In this video, we will share some good practices for safe working on or near fragile surfaces. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, report any fragile surfaces in your work area to your supervisor. A fragile surface is one that may not support your weight. Examples include roof skylight, rusted metal sheet, glass and plastic roof panels that cover an opening which you can fall through. Recall, fragile surfaces was discussed in detail in a previous video. Next, do not enter an area with fragile surfaces unless you are authorized. So, do not enter if you are not trained or do not understand how to work safely on or around fragile surfaces. And do not enter if you were not briefed on the locations and hazards of fragile surfaces in your work area. Ensure that you are protected before stepping on a fragile surface. Always follow the safety control measures before you enter an area with fragile surfaces. Feel free to check with your supervisor if you are unsure if a surface is fragile. As shown now on screen, if access onto a fragile surface cannot be avoided, and where a harness is used, it is important that you ensure that adequate anchorage points are available. Next, keep your work area tidy to prevent tripping and falling on a fragile surface. The following figure shows the wrong practice, the practice which you should and must avoid. Please keep in mind, do not place items or tools that may obstruct your workways and work area. If you trip and fall on a fragile surface, the sudden and high force may break the surface. In addition, avoid working alone on or near fragile surfaces. Always work with a buddy and check on each other's proper use of safety control measures. Stay within your buddy's view and keep in contact with your supervisor. Lastly, do not place tools and materials on fragile surfaces. Discuss first with your supervisor on how to safely load tools and materials onto your work area. Keep in mind here the following basic safety rule. A roof should always be treated as fragile until a competent person has ruled otherwise. In this video, we will share some good practices for safe working near openings. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, understand the control measures if you are working near an open side. In order to do so, you must be trained on how to work safely near an open side, for example, using travel restraint properly. Next, do not use unprotected stairways to access your work area. The figure shown now on screen depicts a typical example of this. Please report any unprotected stairways to your supervisor. And for optimum safety, keep in mind all stairways should be protected with handrails. In addition, we urge you to report any unguarded openings to your supervisor. Openings should be securely fenced or covered to prevent falling hazard. They should be guarded at all times, even during breaks. Next, do not remove any guardrails unless instructed by your supervisor. You will be amazed by the number of craftsmen and scaffolders failing to address this common sense safety rule. In addition, do not move a cover for an opening as you will create a falling hazard. We encourage you to make a planned tour at your facility and make sure that all covers for openings are safely secured and cannot be easily removed. Lastly, ensure that the guardrails and covers are in good condition before you start work. Inform your supervisor immediately if you see any missing, incomplete, or damaged guardrails or covers.
In 2018, the construction of 3 two-story townhouses commenced. The principal contractor engaged a subcontractor to manufacture and erect steel frames for the townhouses. On the day of the incident, workers started erecting steel framework on the first floor of a townhouse. Workers accessed the first floor using a ladder. The site supervisor engaged by the principal contractor was also on site. A stair void approximately 3 meters wide by 1.8 meters long had been cut out of the floor in preparation for a stairwell to be installed. One of the workers was on the first floor, attempting to undo some cross-bracing on the frames when he fell backward, stepping into the uncovered stair void and falling to the concrete ground floor below. The worker, a 19-year-old apprentice, suffered serious injuries from the fall. The principal contractor had organised for scaffolding and stair void protection to be installed. This did not happen due to difficulties with site access. However, the site supervisor engaged by the principal contractor allowed work to start on the first floor. At the time of the incident, workers were not required to wear harnesses on the first floor while the stair void was uncovered, nor were harnesses made available to workers. The injured worker did not hold a general construction induction card and had not been inducted onto the worksite. An investigation into the incident identified the principal contractor failed to undertake a risk assessment or verify one had been conducted in relation to working from heights and the need for adequate fall protection. Ensured appropriate fall protection and penetration covers were installed at the site. Prohibit workers working on level 1 until adequate fall protection or penetration covers had been installed, and ensure injured worker held a general construction induction card and had been trained and understood the risks to health and safety arising from working at heights. The subcontractor failed to conduct a risk assessment for working at heights, install devices to protect all voids and penetrations, install fall prevention devices such as edge protection, working platforms, and or scaffolding. Prohibit workers from working on the first floor unless voids and penetrations were protected and adequate fall prevention devices were installed. Ensure workers were trained and understood the need to ensure that voids and penetrations were protected. Provide information, training, instruction, and induction to workers in relation to the risks while working at heights. Prohibit workers from working on site if they did not hold a general construction induction card, and inspect the worksite before work was conducted to ensure it was safe.
Okay, now in order to perform a work at height, you need first to access the working area, and there are many different types of access equipment. In this course, only the following categories will be considered here. These are ladders, scaffold, whether fixed or prefabricated mobile scaffold towers, and mobile elevating work platforms, more commonly referred to as MEWP. In this video, we will provide valuable insights into the correct way of using ladders. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, check that the ladder is safe before use. As seen in this example, for optimum safety, spreaders should be able to extend fully. Next, ensure that the ladder is stable before use. As depicted in this example, the base of the ladder should be secured. For optimum safety, the ladder should be tied at its top or near its base, as shown now on screen. It is also important to place the ladder on stable and level ground. Next, do not stand on the top rank of a ladder. The bottom line here, the height of a ladder must be suitable enough so that you do not overstretch. Always maintain 3-point contact, as highlighted here. By 3-point contact, we mean using 2 hands and 1 leg, or 1 hand and 2 legs on the ladder. Always use a suitable ladder to carry out the work. For this, choose a ladder that is suitable for the job, and do not use items such as chairs or boxes to replace the ladder. Lastly, set up the ladder at a safe place. The figure shown now on screen depicts the wrong practice. Please, for your own safety and the safety of your co-workers, do not set up ladders in passageways, doorways, or near the edge of an open floor or on scaffolding. You will be amazed by the number of times you will see ladders on scaffoldings in refineries and chemical plants. It is your duty to correct these deviations. In this video, we will provide valuable insights into the correct way of using scaffolds. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, check that scaffold is safe for use before using. Look for the Safe for Use tag at the scaffold's access point, as depicted in this example. Report to your supervisor if you are unsure or do not see the Safe for Use tag. Next, do not stand on objects to gain height on a work platform. The guardrails will not be effective to prevent you from falling. And it is needless to say that it is unsafe to climb onto guardrails. Next, do not carry unauthorized tools and materials to prevent overloading the scaffold. Check that the work platform is safe before stepping on it. For this, there should be no openings except for the access ladder. In addition, work platforms should be at least 50 centimeters wide with no big gaps between, as highlighted in this example. Next, do not move a mobile tower scaffold when anyone is on it. You will create a serious fall hazard, as shown now on screen. Thus, do not access or work on a mobile scaffold until all wheels are locked. Lastly, do not change or remove any part of a scaffold. As already stated, you will be amazed by the number of craftsmen and scaffolders failing to address this basic safety rule. If you see this on the field, it will be your duty to implement corrective actions. In this video, we will provide valuable insights into the correct way of using mobile elevating work platforms. Please feel free to share these good practices with your colleagues to enhance safety at your workplace. First, only operate a mobile elevating working platform if you are trained and authorized. When working on a mobile elevating working platform, always follow instructions from the authorized operator. Only use the mobile elevating working platform for the task your supervisor asked you to do. Do not use the mobile elevating working platform to lift equipment or to maintain or support structures, piping systems, or any other type of equipment. Do not use the mobile elevating working platform if it is not suitable for the job. For example, do not use it if it is not high enough to reach your work area, as highlighted in this example. In addition, do not use it if the ground is too soft, uneven, or slippery. Always keep both feet on the work platform at all times. Do not climb onto the guardrails. Although this seems a common sense practice, you will be amazed by the number of operators failing to meet this basic safety rule. In addition, do not anchor your lanyard to the guardrail. Guardrails should never be considered as safe anchorage points. Your lanyard should be connected to a certified anchor point inside the mobile elevating working platform. And again, let me be clear one more time, stand on the platform and do not climb on guardrails even when connected. Next, do not turn off any safety devices of the mobile elevating working platform. So pay attention to any safety alarm when operating and working on your mobile elevating working platform. And of course, do not use the mobile elevating working platform if any of the safety devices doesn't work. Lastly, protect your mobile elevating working platform from other moving vehicles in the area. You can implement control measures such as setting up barricade or fences around your equipment. Lifting operation is an integral part of any construction or manufacturing process. Every lift carries a set of risks that needs to be managed in order to prevent an accident from occurring. Unsafe lifting operations in refineries and chemical plants can result in catastrophic outcomes involving multiple fatalities and serious injuries, as well as extensive damage to properties and facilities. The following pictures depicts this. The next couple of videos have been prepared based on the collective experience from past accidents and good practices in safe lifting operation. They will provide you with valuable guidance in the planning and execution of a lifting operation. Please note here that this section is not intended to provide technical details on any specific lifting equipment. As a result, we strongly recommend you to consult your manufacturer or supplier when more technical details are needed. Before the lifting operation, the contractor, the employer, and the owner should ensure that the responsible persons for preparing, operating, erecting, disassembling, and using of cranes are well trained in safety and operating procedures. They should develop safety plan and safety working procedures, brief all relevant staff about the plan and procedures, and clearly assign individual safety responsibilities. In any lifting operation that will be carried out at your facility, you will notice that there are 4 key players. These are the crane operator, the signaler, the rigger, and the lifting supervisor. Let's examine the roles and responsibilities of each player. The crane operator should operate the crane in accordance with the manufacturer's guidelines and safe working procedures. The crane operator should fulfill the following requirements. He should hold a valid training certificate. He should be sufficiently trained with knowledge in operating the crane, and should only follow the instructions of one signaler. He must be familiar with hand signals used by the lifting team and use of walkie-talkie to execute the instructions of the signaler, as it will be explained in a later video. In addition, the crane operator should pay attention to the lifting zone. If any unauthorized entry is observed, the lifting operation should be suspended. The signaler should be responsible for transmitting the signal of the rigger to the crane operator, as seen here. The signaler should be responsible for the crane movement and should fulfill the following requirements. He should hold a valid training certificate on general signaling principles and practices. He should understand and be familiar with the hand signals used by the lifting team. In addition, he should be able to clearly and accurately deliver the instructions to the rigger, and he should also pay attention to the lifting zone. Here again, if any unauthorized entry is observed, the crane operator must be notified immediately, and the person should be warned to leave. The rigger should be responsible for loading and unloading the load from the crane. He should use the correct lifting gears and rigging method according to the lifting plan. The rigger should fulfill the following requirements. He should hold a valid training certificate on the principles of using general rigging. He should fully understand the hand signals and radio communication signals used by the lifting team, and should also pay attention to the lifting zone. If any unauthorized entry is observed, the crane operator must be notified immediately, and the person entering the lifting zone should be warned to leave. Lastly, the lifting supervisor is the leader of the lifting team. His duties should be performed according to the requirements in the lifting plan. The lifting supervisor should meet the following requirements. He should be sufficiently experienced and preferably with safety training on lifting supervision. He should ensure that the lifting team knows the lifting plan requirements and takes all practical steps to implement the lifting plan. And if there is any unsafe situation, unsafe behavior, or any deviation from the lifting plan, the lifting operation should be immediately stopped. Hand signal means a movement or position of the arms or hands, or a combination of both, in coded form for guiding persons who are carrying out maneuvers which create a risk to the health and safety of people at work. A typical example of risky maneuvers where coded hand signs are used is lifting operations. It is important that you are familiar with these codes for your own safety. These coded hand signals can be broken down into 4 categories. These are general signals, signals for vertical movements, signals for horizontal movements, and danger signals. The figures that will follow will provide valuable insights into each type. In the first figure, we can see an operator with both arms extended horizontally with the palms facing forwards. This notifies the start of the operation. In this next figure,